3 left to choose from. And the basic counting principle says if we multiply these, that'll tell us how many possibilities we have. Now, it might be helpful to actually have a tree diagram showing those possibilities. So we have red, green, yellow, and white. So I've separated them just because I don't have enough room, but you can put them all vertically, straight up and down. But if I pick the red marble first, remember it's called without replacement, so I don't put the red marble back in. And so my only other choices are green, yellow, and white. If we pick the green marble, then we just have red, yellow, and white left. If you pick the yellow, then it's red, green, and white. Okay. Or if it's white, then it's red, green, and yellow. So I am going to list over here the sample space, which just means all the possibilities. So we can have red and green, red and yellow, red and white, green and red, green and yellow, green and white, yellow and red, yellow and green, yellow and white, white and red, white and green, white and yellow. And if I counted those up, I should get 12. Just like I got for the basic counting principle. So remember, in a nutshell, to find the probability, it's the number of successes, basically the number of ways it can happen, over the total. So for part C, it says find the probability that you pick one green ball. So I'm going to highlight all the ones that have G in them. How many of them are there? 6. Yeah, 1, 2, 3, 4, 5, 6. Out of what was the total? 12. Now you do have to reduce, always. So that's 1/2. So you've got a 50-50 chance of picking a green one. What's the probability that you first pick a white ball and then a black one? 0. Yeah, 0. There are no black ones. So it'd be 0 out of 12, which just reduces to 0 because it's not happening. That's impossible. Remember, 0 is impossible. This top part, you really just need to write that whole thing down. And the bottom one is an example, so you can just write down what's highlighted. The top one's a formula. Okay. So the first part up there is just a formula. A lot of times, not necessarily this one, but if you're trying to find the probability that something happens at least one time, it's easier to find the probability that it doesn't happen and subtract it from 1. Those two are equivalent. They're the same thing. So for this problem, a bag has 2 yellow, we write 2 Y's, 1 green, and 1 blue. And we're going to choose 2 without replacement. So again, we're picking 1 and we're not putting it back in. So if we pick this first yellow one, then I only have 1 more yellow I could pick, or a green, or a blue. Same thing here. Different yellow, green, or blue. If I pick the green, then I could pick the first yellow, the second yellow, or the blue. And if I pick the blue, it again could be the first yellow, the second yellow, or the green. There's our tree diagram to help us figure it out. Remember, sample space is just a list of all the things that can happen. Whoa. So yellow, 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 green, yellow, blue, yellow, 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 green, yellow, blue, green, yellow, green, yellow, green, blue, blue, yellow, blue, yellow, blue, green. Now again, there are 12. It's not always going to be 12. It's just the 3 examples that we had were all 12. They're not always going to be that way. 12 is just a nice one. It's big enough that we can do some stuff with, but not so big that it's just too crazy. Okay, so we can do this the straightforward way. We can say probability of at least one green. So we highlight things that have at least one G in them. Okay, what's going on there? It won't let me highlight that, so I'll circle it. There are a total of 6